no-load test. It's done, it's made to find if you have issues with the core. Actually, it's used to tell you the losses in the core. And how do we do it? The secondary side is disconnected, and we generate on the primary side with the secondary side disconnected. So the first test will be done generating on phase A, measuring on phase B. The second test will be done generating on phase B, measuring on phase C. And the third test will be done generating on phase C and measuring on phase A. So we need to do 3 tests. Just let me tell you that sometimes if you want to repeat the values which you have in the transformers report, which was made in the lab of the transformer producer, it might not be possible because they do it 3-phase generation and probably at higher voltages. Here we have 2 options. We can generate from STS up to 2 kV, but I'm going to use TD5000 and I will generate voltages higher than that. There should be, to the best of my knowledge, some issues with this transformer's core. So for that reason, let's see what kind of tests, what kind of results will we obtain. Let's see how the connections should be done. So I've decided to use the TD5000 as a source, and in this case, of course, I'm generating on the primary side, so you see how the connections should be done if I'm generating on the primary side. First AB, then BC, and then CA. Of course, you can use just STS as a source, but because I have the TD5000, I decided to generate 8000 amps, 50 Hertz. Now onto phase A. I've marked it and I press start. If you do this test just with STS, you are limited when it comes to voltage, of course, but the test is much quicker. This time, since we're using TD5000, it takes more time, a little bit more time, but the results are more accurate and you can generate a higher voltage. As you can see, we can observe what's happening with the TD5000. So we had load evaluation so that the system knows how much power it needs to exert. And now I have a calibration and measurement. So this is now phase A. And the test is done. We see the excitation current is 1.9. Okay. Now we change to phases B and C. As we mentioned before, generally, what we would expect normally as a result, if you don't have any values, previous values, which you made on this transformer, which you measured on this transformer, you would expect phases A and C to have a higher value and phase B to have a lower value. But that's not a rule. It's not necessary that it is like that. It could be different. It depends on the construction of the transformer itself. Let's see what we get here. So here, actually the current in phase B is higher. That was phase 2 or B and C. And now I generate on phase C, measure on phase A. Of course, it is possibility that instead of having the central phase with a lower value, you actually have the central phase with a higher value. But as I mentioned before, it's always good to have previous values of test data. In this case, actually, I know that my transformer is somewhat damaged and I'm not expecting good results. So we have a different situation, phase A, phase C, and the middle phase with a higher current. And this was the no-load test. Thank you.